In this demonstration, we'll take a look at how to perform credential attacks with Mimikatz, including a pass the hash attack. Let's start by getting into a Meterpreter session on our victim system. So the first thing that I'm going to do is I'm going to type in MSF console to load Metasploit. Once Metasploit loads, then I'm going to choose an exploit that I've used to gain access to a system already. So I'm going to use the exploit for Windows against the SMB service, and it's the MS17_010_eternal blue exploit. Now notice that it configures my payload there. It says that no payload has been configured, so it's going to default to Windows x64 Meterpreter reverse TCP. Now the reason why I mention that is you do want to make sure that the payload that's selected is in a 64-bit version versus the x86 version. And in this case, it is the 64-bit version of Meterpreter. So it means when I exploit the system, it's going to put me in a Meterpreter session, which is a great tool to use for post-exploitation, including performing password or credential attacks. Once I've gone and selected the exploit, now I want to go and set my options. So I'm going to go and set my rhost value to the victim's IP address. In this case, it's a Windows client machine, which runs at 10.0.0.10. Now that I've got all that set, I'm going to exploit the system. If it's successful, it'll show a win at the bottom of the screen. And there we go. So it was successful. Notice that my prompt has changed. I'm in a Meterpreter prompt. And at this point, I could use any of my Meterpreter commands. But what we want to do in this example is we want to focus on using Mimikatz to perform credential attacks. So I'm going to use the load command to load the Mimikatz module. Now, one thing I want to stress here is that the commands have changed, and they even give me a little yellow explanation point there, and they say, hey, this Mimikatz extension has been replaced by Kiwi. So really the command I should have used was load Kiwi, but most people know this as the Mimikatz module, so that's why I wanted to use it, knowing that it would still work. So it says at the bottom of that output that it was successful in loading the Mimikatz module or the Kiwi module. And at this point, there's a number of commands that we can use. And if you want to see a list of the commands, you can use the question mark. So just to highlight a few examples of commands, if I want to take a look at any credentials, so Mimikatz is a module that we can use to extract passwords from memory of the victim system. So the creds_MSV will extract out the NTLM hashes from memory. So any user accounts that have authenticated on that system with the credentials still sitting in memory, it'll go and show those credentials to me. The other thing is that there's a creds_Kerberos, which will retrieve any Kerberos credentials and display those. Again, that's from memory. But we also have a command here to do a SAM dump. So if I want to retrieve all the password hashes from the SAM database of that system, I can use the LSA_dump_SAM command. And there's other commands here. You can do a password change on an account if you wanted to. I can get a list of Wi-Fi networks that the system is configured to connect to. So all kinds of different things that I can do here. So just to kind of show you a few examples, the first thing that we're going to use is we're going to use the creds_MSV, which will show any of the password hashes that exist in memory. So this client machine, somebody has logged on, and they logged on as the administrator, and there's our NTLM hash, which is awesome. So what you're doing at this point is you're kind of making a note of, okay, we have a username called administrator. The domain in this case is just a local workstation logon, so it's the name of the workstation, Win7a, and NTLM, we grab the password hash. So you kind of start collecting that information. Now what's really cool is if you use the creds_Kerberos command, it'll actually show that password in plain text, not just the password hash. So now I'm collecting information about, usernames and passwords that are still stored in memory on this target system. So I can see there's a username called administrator on Win7A with a password of capital P A $$W0RD, which is awesome. Now, the other thing that we can do as well is we can dump the entire SAM database. So I can do an LSA underscore dump underscore SAM. And what happens here, if I scroll up in my output, is we can see all the user accounts and their password hashes. So again, what you'll do is you'll collect this information. So we already know the plain text password for the administrator account. So I don't think there's a lot of value in grabbing that password hash, although you still may want to grab the password hash. But notice that we do see other users on the system. So there's a user account user1, and we have the password hash for that user account. We have user2, user3, and notice that the password hashes are different. So there are different passwords used on these accounts. So what you could do is you could collect that information. Now, also what you can do with Mimikatz is you can fire off custom commands. So there's a whole bunch of different commands that you can fire off. And with the Kiwi extension here now, to fire off a custom command with Mimikatz, it's Kiwi underscore command, and this was in the help there. And then in single quotes, you plug in the custom command. This will take a little bit of getting used to. The commands are in two parts. So the first part is the category of commands. So this is the secure LSA. And then we do : and you specify the action on what you want to do in the secure LSA category. And the action, there's an action called pass the hash. So I do : PTH space, and then you specify any parameters that it would need. So for instance, I can do the user that I want to authenticate in or as is user6. The domain, in this case, it's just the Win7A system. And then we can do an NTLM : and what we can do here is we can pass in the password hash of that user6. So I'm just going to copy that here. So I copy selection. I'm just going to paste it in with my command there. And then what you could also do is you could specify, not only do you want to authenticate to the system as user6 using, instead of trying to crack the password, I can just pass in the hash value is kind of the point here. But the other thing you can do as well is you can go and specify that you want to run a command. So I could do a /run, and I could do cmd.exe. Hit enter, and it comes up and gives me feedback here. It says, okay, you've authenticated as user6 on the Win7A system, and you're running the program cmd.exe, and they show the process ID here as well. So the point is, the pass the hash feature allows you to authenticate to a system without trying to figure out what the plain text password is. So you could use a password cracking tool and you could crack the password hash, but sometimes that could take quite a bit of time. So the idea here is that Mimikatz gives us the capability to authenticate to the system using the password hash if you use that /NTLM switch. So in this video, you saw how to perform credential attacks or password attacks using Mimikatz. In this demonstration, you'll learn how to use Rubeus to perform attacks against Active Directory. Let's start with a quick description of Kerberosing. Kerberosing is an attack that tries to get the password hash of an Active Directory account that has a service principal name associated with it. A service principal name, or SPN for short, is an attribute that associates an account with a service on the network. This SPN is then used in Kerberos authentication for clients to obtain a ticket to access that service. The attack here is that anyone can request a ticket from the service which contains the password hash of the service account being used. Once the attacker obtains the password hash, they can then crack the hash offline using a tool such as Hashcat and then impersonate that account. Rubeus is a tool that can request for a Kerberos service ticket, which contains the password hash that will then crack offline with Hashcat, but you could also use John the Ripper as well. Let's start by using Rubeus to send a request for a ticket. So we use the Rubeus command. We specify our option on Rubeus. So in this case, we want to use it to perform Kerberosing. Now keep in mind that Rubeus can be used for different tasks or attacks against Active Directory, including obtaining what we call a silver ticket, which means getting a min level access to a service itself. So here we're going to do Rubeus Kerberos. Then we specify our domain. In this case, we're in the quick 24/7.loc domain. You specify the credentials of a user account on the network. So this is important because any user on the network can request a service ticket from Active Directory. So here all I need is just regular user credentials. I don't need a min-level access to send this request. So the credentials that I'm going to use, and when you specify your credentials, you do have to specify the domain again. So quick 24/7.loc/. And the user account that I'm going to use is tsmith. So I would have obtained this user's password in a previous attack. And then I'm going to specify the password for this account is capital PA $$W0RD. That happens to be the password I'm using for all the accounts in my lab environment here. Now I am going to specify the no wrap option here. And what this is used for is when the Rubeus sends out that request for a ticket and we receive that ticket, the actual hash that's used to encrypt the ticket is going to display on the screen. And in order to be able to copy and paste that properly, we have to specify that we don't want a password hash to be wrapped. So I'm going to fire this off. And when I hit enter here, it shows that we do have one service account in Active Directory. It's an account called the SQL Service account. We can see the distinguished name of the account. So this is the full distinguished name. So it's CN equals SQL Service. It's in an OU called Service Accounts and in a domain called quick 24/7.loc. We can actually see the service principal name here as well. So this is the service account that's going to be used by Microsoft SQL Server. And then we have the password hash. So what you can do is you can select this password hash. So this is a Kerberos hash. And you can copy it. So I can highlight it and hit enter. And that'll copy it to the clipboard. And then what I can do is paste that into my next command, which is to use Hashcat. Okay, so what I've done here is I've switched over to my real computer because that computer has a GPU that Hashcat can use to crack the password hash. So to crack the Kerberos password hash, we're going to use Hashcat, and then in quotes, we're going to paste in the password hash. Perfect. I'm going to close the quote, and then I'm going to specify the dictionary file that I want to use for the password cracking. So in this case, it's example.dict. This is the sample dictionary file that comes with Hashcat. What I did is I modified it and I actually put our password in there just for the demonstration. I did put it pretty far down in the file, so it'll still take a few minutes for it to be able to crack the password. So I hit enter, it executes our Hashcat program, and within a minute, it finished the password crack. So very quickly, again, for the demo, I put the actual password in there. So you can see up top here, if I scroll up, so it is using Hashcat and it is using my GPU to perform the password cracking. Down below here, they show us the password hash, which we've supplied. But notice right after the password hash is a colon, and there's our password. So capital PA $$W0RD. Down below that, we can see the Hashcat program has cracked the password, shows you the start time and the end time. So again, it happened very quickly. And that's it. So now we have the password for that service account. And that service account, we can log in with that and access Active Directory, and it may have permissions to different Active Directory resources. In this case, it's the SQL Service account, so it'll have access to the SQL Server. You can then turn around and use this password with that user account, that SQL Service account, to then issue it a request for a silver ticket to get a min-level access to the SQL Service if you wanted to as well. So all kinds of things we could do once we have the password for the service account, but we can now impersonate that service account. So in this demonstration, you saw how to use Rubeus and Hashcat to crack an Active Directory password. In this demonstration, you'll learn about Certipy, a penetration testing tool that can be used to leverage weaknesses within Active Directory certificate services. So the first thing that I want to make a note of is that the newer version of Certipy is now called Certipy-AD. So if I do a Certipy-AD command all by itself, it'll display the help for the command. Or you could use the Certipy-AD-H to display the help if you wanted to. But typing the command all by itself without any parameters will display the help. And they show you the general syntax. So it's Certipy-AD. Again, the older version was just called Certipy, but now it's Certipy-AD. And then they show you your command switches that you can use, and then the actual commands. So there's an account command you can use, there's an auth command for authentication, there's a CA command, there's a cert command, and so on. And then what they do is they give you a list here in the help of what the general purpose of each of those commands are. So the account command will manage user and machine accounts, whereas the auth command will authenticate using certificates. The CA command will manage CA and certificates, and so on. I want you to notice that there is a find command, because that's going to be our first command that we use, and the find command is used to enumerate through Active Directory certificate services. And also notice that we do have a request command as well, which is used to request a certificate. And those are two examples of commands that we're going to use here in this demonstration. So I'm just going to clear the screen. So that's how we display the help. So note that we did see that there was a find command that we want to use. So what you can do is you can do Certipy-AD, use the find command. If I've never used that command before, I want to do a -H on that to get the help of the find command specifically. And you can do that with each of the commands. So when I look at the help for the Certipy-AD find command, they give you a list of all the options with an explanation of what each of the parameters or what each of the options do. So that's important to kind of know as we get started here. So I'm going to clear that screen. So I do want to use the find command. So I'm going to use Certipy-AD --find. Now when I use the find command, what I'm going to do is I'm going to authenticate with a user account. So tsmith@quick24/7.loc. The password for that account is capital PA $$W0RD. So that username and password you would have obtained in an earlier step within your penetration test, right? I do want to stress that this is just a regular user account. So one of the things with certificate services is that users can send search requests and discover information about certificate services and its vulnerabilities. So I'm going to specify the IP address of the domain controller, again, which you would have discovered earlier on in the penetration test. So the IP address of the domain controller is 10.0.0.1. So I hit enter. And basically what happens here is Certipy goes and contacts Active Directory and discovers information about certificate services. So the vulnerabilities that it can leverage come from vulnerabilities within what we call certificate templates. A certificate template is a basis for different types of certificates that can exist. So for instance, a user certificate is generated from a certificate template called user. A server certificate, which you can use for server applications, let's say, it is generated from a server certificate template. So every certificate that's generated in certificate services is based off a template. So the template defines the types of certificates that can exist. And then the other thing is the certificate template contains the options or settings for that type of certificate. So my point here is a lot of the vulnerabilities come from these certificate templates. So it says that it's finding certificate templates. It found 34 certificate templates. It also found the certificate authority. So it found one certificate authority. The certificate authority, or the CA, is the entity that's going to issue out certificates within our PKI infrastructure here. Perfect. So it kind of gives you just a little bit of info on that. It says got CA configuration for server A. So server A is the actual CA. And then it specifies that it's basically outputted the information to a Bloodhound file, or it also outputted to a text file that we could view. So I just want to view this. This is going to be a huge file, but just to show you, we're going to use cat space 2024. I'm just trying to think how I can, let me go to a previous command to save me from typing all those numbers out. And then I'll just update it somewhere here. There we go. So 2024-1219, and then it's 132138. So it's based off the date and time. So when you're running this on your own system, you'll have a different file name. The great thing is they tell you the file name right there on the screen. So I just got to make sure I have no typos as I type that out. So I'm going to double check it here. 2024-1219. 132138 underscore certipy.txt. Perfect. So like I said, this is going to be a huge file. And when I scroll up, not insanely huge, but I just want to scroll up, show you the contents of the file. Okay, so I'm at the top here. There's me issuing the cat command to display the contents of a text file. There's the name of the text file. So in the contents of the text file, they do show you information about certificate services. So this is important information that I need to collect and document. So the name of the CA is server A, and I'm going to need to know that in my next couple commands, or I'm going to have to supply that, I should say, in my next couple commands. The DNS name for this certificate authority, or CA, is servera.quick24x7.loc. They show some information about the certificate server there. Perfect. And then when I scroll down, they show some permissions. So the owner is administrators, access rights. These are the people that can enroll certificates, so authenticated users, read certificates, manage certificates. Authenticated users can manage certificates and manage the CA. Notice that authenticated users can, which is not normal. So I did basically unsecure the CA so that the demo would work. So what they're doing here now is they're going to show you some vulnerabilities. And this is what's great about this Certipy tool, is that it's going to list out different vulnerabilities. The vulnerabilities are actually identified by an ESC number. So each number identifies a different type of vulnerability. So ESC7 means that authenticated users have dangerous permissions, or I shouldn't say specifically authenticated users. Somebody's been granted dangerous permissions and they're identifying what group it is. So if I'm assessing the security of the CA, I would make note of that vulnerability and I would want to lock things down a little bit, right? So I would go and find out, okay, why do authenticated users have the extended capabilities or permissions here? And can we remove those? And those permissions should be removed. ESC8 is the fact that the web enrollment tool is enabled. That's a website that allows people to request certificates. Now, remember we said that a certificate template is a definition for a type of certificate that can be created or issued by the CA. So now what they're going to do is they're going to list out, and this is why the output is so long here, they're going to list out each certificate template and information about each template. So the very first template is called Quick 24/7 User. Again, I'm making a note of that because that's something I'm going to supply in one of my future commands, okay? And then down below, they'll give you information about that template. So server A, it is an enabled template, which is important. It's used for client authentication, so for clients to authenticate to the network, and so on. And they go and show permissions on this template. And again, all the information about each template. So then they show the vulnerabilities. So this is the vulnerability that I want to exploit here is the ESC1 vulnerability. So they're saying, hey, this certificate template is vulnerable to ESC1, which is the fact that domain users and authenticated users can enroll or create a certificate off of that template. And what's important here is I can do that for an administrative type account. So the purpose of this demo is I'm going to request a certificate as Tom, as T. Smith, who's a regular user, and I'm going to request a certificate for the administrator. And then what I'm going to do is I'm going to try to obtain the password hash from that request so that I can then turn around and crack the password of the administrator account. That's our vulnerability here. So they do show each of the templates. I'm not going to go through every one of these templates, but basically that's what you're seeing here in the output. Now, my point is that output is very long. So what I can do is I can shorten that up a little bit by saying, let me use my up arrow key. So Certipy AD, I want to find information about our certificate services environment, but specifically, I want to find information about certificates that are vulnerable. And then I supply my username and password. And again, I'm just logging in as the T. Smith account and then hit enter. Now, my point here with this example is because I've added the -vulnerable switch, the output is going to be much shorter. So what I'll do here is I'll cat that out, which should be 12.19133.010_certipy.txt. Okay, so let me display this text, this information out. And I want you to see here the output is quite a bit smaller. Like I had to scroll up for quite a bit of time there a few minutes ago because I was getting all kinds of information. Now I'm just saying, show me vulnerable information. You do get information about the CA, the certificate authority. So I do need to know what the name of the CA is and what the DNS name is. That'll be important for my next two commands. And then down below here, notice that they do show the vulnerabilities with the CA, and they show the certificate template, the Quick 24/7 user certificate template, and they show its vulnerabilities as well. So it's vulnerable to ESC1, which means that authenticated users can enroll a certificate and supply a subject name. Perfect. So that's the first thing. The find command was used to discover information about certificate services environment and also discover vulnerabilities with that environment. Very cool. So our next command is we're going to request as Tom, which is just a plain old user, we're going to request a certificate for the administrator. Okay, so our next command is Certipy-AD. This time, instead of the find command, we're going to request a certificate. And we're going to specify our user credentials. Again, I'm going to impersonate the Tom Smith account. So I supply Tom's credentials, which I would have obtained in a previous step within my pen test. And then we're going to go and supply the password. Then we need to specify the name of the CA. And remember, this information was in the find results. So the name of the CA is server A. And I do want to stress, notice that I'm putting the values of like logon names, passwords, server names in quotes. And a big reason for that is there could be special characters used, like the $sign. So you want to make sure it's put in single quotes. That way it's treated as just a string value. I'm going to specify the target server is server a.quick24by7.loc. Again, that information was obtained from the find command. Then we specify the template name. So when we request a certificate, we got to specify what template that defines the type of certificate that's being requested. And it's going to be a user certificate based off of the Quick24by7 user template. I'm using this certificate template because it was vulnerable. And then I'm going to specify the UPN, the user principal name of the account that I'm requesting the certificate for. Notice that I'm supplying the account for the administrator email address. And then I specify the IP address of our domain controller of 10.0.0.1. Hit enter, and it says that sending a request for a certificate via RPC communication successfully requested the certificate in our second line there. Perfect. It says that it got the certificate with the UPN of administrator at quick24by7.loc. And then it saved the certificate and the private key for that account to a file called administrator.pfx. So if I do an ls command here, you can see we do have a file called administrator.pfx. Perfect. So that's the administrator's certificate, which contains the administrator's private key. So the last thing I want to do here is extract the authentication information from that certificate, which will contain the password hash for the account. And the goal here is that with Certipy AD, I can get the password hash, and then you can crack the password hash with your password cracking tools. So my last command, Certipy-AD. This time we're going to use the authentication command, so the auth. I'm going to specify the pfx file, which is administrator.pfx. And the domain controller's IP address is 10.0.0.1. Hit enter. So it says that it has saved the credential cache for the administrator in administrator.c cache. It's trying to retrieve the NT hash for the administrator. It got the hash for the administrator, and here's the hash value. So the point is we could then turn around and crack that with our password cracking tools, which will then give us the password for the administrator account on the network. So in this demonstration, you saw how to use Certipy to identify vulnerabilities in Active Directory certificate services and exploit those vulnerabilities. In this demonstration, we'll take a look at how to perform safety checks using a program called Seatbelt. Seatbelt is a program from the GhostPak suite that can be used to perform a number of security checks on a system. For example, you can use it to check the antivirus software status, you can check to see if AppLocker is blocking any applications, and you can use it to view the audit policies on a system. You can also use it to view the auto-run settings on a system and enumerate browser history and bookmarks of that system. These are just a few examples of information about a system that can be extracted using Seatbelt, but keep in mind there's a ton of information that can be retrieved about a system when you use the Seatbelt program. The different types of information are presented in what we call groups. You can think of these groups as categories of information. For example, there's a Chromium group to view web browser data or a user group to view user information. Let's take a look at how to use the Seatbelt program. So the first thing we want to do is we're going to use the Seatbelt program all by itself. When I do that, what's going to happen is it's going to display the help for Seatbelt. And within this help, there's a ton of information. So I'll scroll up to the top here. First thing is you'll see the seatbelt logo. It kind of shows a seatbelt, the left side kind of connecting to the right side of a seatbelt. And then down below that, they show you a list of available commands where the plus sign means that the command can be executed against a remote system. So just to highlight a few things that we can collect here, you can get information on antivirus software, on the app locker. You can view the ARP table of a system if you wanted to. You can review the audit policies, the auto run section of the system registry. So it can retrieve that and report that to you. The history and the bookmarks that are set up within the browser itself, the DNS cache, information on your .NET versions that are running on the system. So Seatbelt uses WMI to collect a lot of this information about a target system. You know, your FileZilla history and configuration files, all kinds of different pieces of information, different IE tabs that are open, your favorites, your URLs, last shutdown time, any group policy objects, local GPOs that are being applied to the system, information about the local users and the local groups and what users are inside those groups. You can also retrieve information on things like PowerShell. So your PowerShell commandlets that have been executed in the PowerShell history. You can get a list of printers and processes from that target system. All kinds of stuff here. We also have information about SCCM. So any SCCM settings that exist on the system. Information about services. UAC settings. Also Wi-Fi profile settings, all kinds of different types of information, and then information about WSUS as far as WSUS settings go. So all kinds of information. Now what I like is down below that, the help shows you your different commands that you can use to retrieve data from different groupings. So for instance, if you want everything, you can use seatbelt-group equals all, and that'll run all commands. But if you just want to see the user data, then you would go and do seatbelt-group equals users, and they give you an idea what commands would execute if you go and retrieve the user group. So you'll get all the certificate information on the system. You'll get things like most recently run programs or most recently used programs from that system. You'll get the FileZilla information. You'll get the browser information as well. You'll get map drives, IE favorites and tabs, all kinds of information here, right? So that's all the different types of commands that execute if you just fire off the -group equals user. So they give you that breakdown for each of the different groupings. If you do a seatbelt-group equals system, then it'll go and fire off your antivirus commands. You'll get app locker, the auto runs, you'll get your policy information about that system, all kinds of details, OS information, all kinds of details about the system. If you just want your browser information, right, then you can go with seatbelt-group equals Chromium, and it'll give you your history and your bookmarks and stuff like that. So that's kind of the idea, being able to read the help and also using the groupings. So I'm going to show some of these groupings here. And the first one, let me do a clear screen here. The first one is I'm going to do a seatbelt-group equals all. Now this will take a few minutes to execute because it does retrieve all the information about the system. So we'll just let that run. It'll take a few minutes and then we'll kind of review some of the output. Okay, so it finished up. Now let's go to the very top. And what I want to do is just highlight some of the information that is displayed here. Okay, so here's me running the command, seatbelt-group equals all. There's our logo. First thing is they give us information about our antivirus software. So it looks like we're using Windows Defender on the system. Down below that, they give us additional information, if they can, about the antivirus software. So it looks like it couldn't retrieve any additional information. And you can see here a little bit of a WMI call that's being executed, but there's no data to retrieve. AppLocker is the program in Windows that allows you to go and block applications from running. So we can see that AppLocker is not being used on the system, which means that there is no blacklisting of programs, which is important from a pen tester point of view to be aware of. We can see the ARP table, any addresses that have been resolved recently. We can see per interface, so it looks like we've got some MAC addresses of different IP addresses there for both a 192.168.2 network and a 10 network. So those are live systems on the network, which is important, so I may document that. Underneath that, we have, so this is the auto run section. So they're showing you programs that are set up to run automatically. So it looks like there's only one program on the system that's set to auto run. Again, very important information when assessing the security of a system. We have information about the certificates that exist on the system. So number of different certificates there, certificate thumbprints. Here's where they have our browser history, right? And any bookmarks. So it looks like there's no bookmarks on the system. And then we have some browser history. So you can see here, navigating to, looks like the Hashcat site, that kind of idea. Perfect. So more browser history. Down below that, we have, this is interesting. So it's doing a directory listing of the file system. So it's showing you some different folders and files that exist. So you can kind of navigate through that and get a listing of the different files. So there's some of the programs that I've been using in some of the demos and stuff like that, right? So very interesting. So there's a file listing. There's your .NET versions that are running. All kinds of data or information here that's being retrieved. Environment variables and environment paths. So they'll go through different environment variables here. Those are the paths, but eventually I should see some environment variables. There's the environment variables and what their values are set to. So for instance, there's the OS environment variable and it's set to Windows_NT. So again, just an example of the type of information that's being retrieved here. All kinds. Most recently used, Explorer most recently used, so different files that are used on the system. Firefox and IE settings. Installed software on the system. Looks like Nmap has been installed on the system. Wireshark has been installed on the system. So as you can see, lots of information. As I scroll down through this stuff, we'll also see user information. So users and groups. So I'm just kind of scrolling by all the software stuff. Here's some interesting files that exist on the system. Interesting processes that are running. Internet settings. Last time the system was shut down. These are non-empty local groups. So these, and it shows the members. So the administrators group has these accounts inside of it. So that's important from a security assessment point of view. I can see here that there's a G Clark account in the administrators group. So next I would wonder, is that a valid account in that group? Should that account be in there? Great tool, gives us lots of information to review. So again, it shows all the different groups and who's members of those groups. And then shows our user accounts as well. So there's an administrator account, there's a guest account, there's an Alan account, there's a Marcia account, and so on. So all kinds of information collected. Now the last thing I want to show you here is that if you didn't want to collect all the information, you could call upon a specific grouping. So for instance, I can do Seatbelt space -group equals, and let's say I want the browser data only, I can call upon the Chromium and it just shows the browser data. So you're not getting as much output. And again, this could be written to a file as well, which is important. So you could output to a file for reporting purposes. So that's our Chromium information. If I want the user data, I can do Seatbelt -group equals user. And that'll just give me the user data. Quite a bit more there for the user data, but we can see our users and we can obtain group information as well, which is all important information. So, and all those groupings are inside the help there, which is very useful. So use the help for Seatbelt to guide you in your commands and what commands you want to execute. So in this demonstration, you saw how to perform safety checks on a system using Seatbelt. In this video, you'll learn how to exploit a system using PsExec. PsExec is a common tool used by Windows administrators to run a program on a remote system. For example, an administrator can use PsExec to launch a command prompt on a remote system and perform administrative tasks on that system. The remote nature of PsExec makes it an attractive method to exploit a system and gain full access to that system. PsExec could be used to perform lateral movement on the network as the attacker jumps from system to system. To get started, the first thing that I want to do as an attacker is obtain the administrator's password hash, and then see if I can use that password hash to laterally move from one system to another using PsExec. So to get started, I'm going to exploit the Windows client, which I know I can exploit because I've already exploited that in previous stages of the penetration test. So the first thing that I want to do is go to MSF console to launch Metasploit. Once Metasploit loads here, next thing that I want to do is I want to load the exploit that I want to run to exploit a Windows system. Now in this case, I'm going to exploit a Windows client. Like I said, a client that I know that I've had access to already. So I already know the exploit I want to use. I'm going to use exploit Windows SMB MS17 Eternal Blue. So that's a common exploit against the SMB service on an unpatched Windows system. Now the next thing I want to do is look at the options that need to be configured here. So I'm going to use the show options command. So I can see here that the rhost, which stands for the remote host, which is the IP address of the system that you want to perform the attack against, that parameter or option is required and it currently has no value. So I do have to set that one. The next setting is required as well, which is the port to perform the attack against. And notice that that's already filled in. So the only required setting that's currently not filled in is the rhost option. So I'm going to set the rhost to the IP address of the Windows client. So set rhost to 10.0.0.10. Perfect. Now that I've got everything set, now what I'm going to do is just run the exploit. So this will perform an attack against that system. If it's successful, it'll open up a Meterpreter session where I can then go and perform a bunch of post-exploitation tasks. So notice that I'm in a Meterpreter prompt. That's perfect. So I can type in sysinfo just to display the information about the system so I can see that it's a Windows 7 client machine that I've exploited. The other cool thing that I want to do here, and very important, is to obtain the password hashes. So I'll use the hash dump command. And then what I can do is I can copy all these password hashes to a text file and then work on trying to crack the passwords for these different user accounts. So these are the user accounts on this Windows system, and it's being retrieved from the SAM database. Now, what I care about for this demonstration is the fact that there is an administrator account, and because most administrators will use the same password on all the administrator accounts, what I want to do is I'm going to copy this password hash here. And I'm going to use that. So I'm going to copy the selection. I'm going to use this in another attack against a different system without actually trying to crack the password. I'm going to pass that hash value into my PsExec exploit. So I'm going to leave that window open, and what I'm going to do is I'm going to jump to another prompt. So I'm in another prompt here, and I'm going to perform a different attack. So I'm going to go back into MSF console, which launches Metasploit. And once in Metasploit here, I can search if I wanted to for exploits against PsExec. And there's a number of different exploits. Now the one that I'm going to use is the exploit number 4, the exploit Windows SMB PsExec. And I'm going to use this to exploit the system and gain access to a different system. In this case, I'm going to use the PsExec exploit to gain access to a Windows server. So once I've gone and searched for PsExec exploits, now what I'm going to do is I'm going to use exploit Windows SMB, and I'm just typing in the PsExec. I'm just typing in the path to the exploit I want to use. That's displayed up top here in my search results. So again, that number 4 was exploit Windows SMB PsExec. Now, again, you want to do your show options just to see what options need to be set here. So notice that we have to set the rhost option, which is the remote host of the system that we want to perform the attack on. Perfect. So I'm going to do a set rhost to 10.0.0.1. And then I'm going to set my local host address to 10.0.0.7, which it was actually set to anyway, but that's okay. Now, 2 other options that I want to set here is, notice that there is an opportunity to supply a username and a password. So this is the SMB, is the core protocol that Microsoft uses for file sharing. So I'm going to supply my Windows username of administrator, and instead of the password, I'm going to pass in that hash that I obtained through exploiting a totally different Windows system on the network and see if we can perform some lateral movement. So I'm going to set my SMB user to administrator, and then I'm going to set the SMB pass to the password hash. So I'm going to paste my password hash in here, which I thought was in my paste. Let me switch back to the other window. And let's grab that password hash right here. Copy selection. So what I'm doing here is I'm kind of betting on the fact that all of the Windows systems on this network are probably using the same password for the administrative account. That may not be true, but we'll find out. So I paste in the password hash as the password for this exploit. Now I'm going to do my show options one more time just to take a quick look. So the remote system is 10.0.0.1, which is a server that I have running, a Windows server. We have the SMB password. Notice that I didn't have to spend the time cracking the password. I'm passing in the password hash. And then the SMB username is administrator. Perfect. So now we're going to exploit this system. And if it's successful, again, I'll be thrown into a Meterpreter session, and it's successful. So I now have access to that 10.0.0.1 system. So if I do a sysinfo, I can see here that it's a machine called Server A. It's a Windows 2016 or above Windows server in the domain quick 24/7. And bottom line is I can go and execute any number of commands here. So if I use a question mark, I have all the different Meterpreter commands. I could do a hash dump on this system to retrieve the Windows account database if I wanted to. I could clear the event logs. I could go and create new user accounts on the system if I wanted to. So I can perform any number of commands on the system. So just as an example here, let me go into shell. That'll take me into the command prompt of the target system. And if I do a who am I can see that I'm logged in as the system account. So I could go and create a new user account. So net user hacker with my password /add. Oh, the account already exists, so I must have already done that. So let me, I don't know if my up arrow will work because I'm in a shell. So net user course 12 hacker. That account won't exist. Perfect. Okay, so it created the account called course12_hacker with the password of capital PA $$W0RD. So my point is, I can go and perform anything, make any change. I can create some hidden user accounts on the system if I wanted to. I have full control of this system. So in this demonstration, you saw how to exploit a system using PsExec. In this demonstration, you'll learn how to use PowerShell in your attacks. Here's the scenario. We know of a vulnerability on a client system within the network. We're going to exploit that vulnerability to obtain the password for the administrator account. We then use that password to connect to a more valuable system on the network, like a server or a domain controller. At any time, we can jump into a PowerShell session and use our PowerShell knowledge to manipulate the target system. Let's get started by performing the exploit on the client system. The first thing I'm going to do is I'm going to go into MSF console. When I type MSF console, it loads the Metasploit program. And now from here, I'm going to select my exploit. So because I've already done a vulnerability scan on the system, I know that the system is vulnerable to an SMB attack, the MS17010 Eternal Blue exploit. Once I've gone and selected the exploit, then I want to set my target system, which is with the rhost value. So I'm going to set rhost to 10.0.0.10 and then run the exploit. Now I do find sometimes that the Metasploit product is a little buggy. If it doesn't work, what I'm going to do is I'm going to just run exploit a second time. So just a heads up if you find it doesn't work. Now in this case it did work. You can see I've got win at the bottom there. And notice that my prompt has changed. I'm now in a Meterpreter session. And within this Meterpreter session, I can perform a number of post-exploitation tasks, such as I want to go and try to retrieve some credentials from the system. But note that I could also go into a PowerShell prompt from here if I wanted to manipulate this system with PowerShell. Now in my demo, I'm not going to do that. What I want to do is let's see if we can grab some credentials and then use those credentials to move laterally across the network. So I'm going to load the Mimikatz module. And from here, I can use the question mark. Notice that at the bottom of my screen, it says success. So it was successful in loading the module. I'm going to do a question mark, and it shows me all my Mimikatz commands. So from here, I want to go and retrieve some credentials. So I'm going to use the creds_msv command. And notice that I can see there's two credentials on the system, one for the administrator and one for user one. And it shows the password hashes there, which is great. I can go in and copy those password hashes and then use a password cracking tool if I wanted to crack the password hashes. But there's another command in Mimikatz that I can use here, creds_Kerberos. And this command will actually show you the passwords in plain text. So I can see the administrator has a password of capital PA $$W0RD, while the user one account has a password of host. So what I'm going to do is I'm going to make a note of that password for the administrator account, and now I'm going to see if I can exploit a server on the network using that administrator's password. Because a lot of times, administrators will use the same password on all their systems. So let's go and open a new prompt. And with this new prompt, what we're going to do is perform a different exploit against a domain controller. So first thing I'm going to do is go into MSF console again. That way I've got Metasploit running in this window. And this time I'm going to use a different exploit. I'm going to use PsExec, which is used to execute commands against remote targets. So I'm going to use exploit Windows PsExec. Use exploit Windows SMB PsExec is the module. There we go, that looks better. Notice that it's loaded, or it's defaulting to the payload of Windows Meterpreter reverse TCP. I do want to use the 64-bit version of that module, so I'm going to set my payload to Windows x64 Meterpreter reverse TCP. Perfect. Now from here, I've got a couple options that I want to set. I can use my show options to view the settings, or the options that need to be set. I do need to set the R host, the remote host of the system that I want to perform the attack on. And in this case, it's going to be my domain controller, which has the IP address of 10.0.0.1. Then I also want to make sure that I set the username and password to use to make that remote connection. So I'm going to use the username of administrator and the password that we obtained from that other system, hoping that the password is the same for all the admin accounts across the network. Now that may not be the case, but we want to try it to see. So I'm going to set my first option, which is set our host to 10.0.0.1. Then I'm going to set my SMB user to administrator. I'm going to set the SMB pass to the password. And then I'm going to exploit the system. Notice that when I run the exploit, again, I'm in a Meterpreter session, which I love because, again, there's a number of post-exploitation commands that I can use there. In this demonstration, what I want to show you is that from this Meterpreter session, if you wanted to, you could jump into PowerShell, or you could execute PowerShell commands. What you need to do is you need to load the PowerShell module. And that way, if you're somebody that's comfortable with PowerShell, you can then start using all your Windows PowerShell commands against that target system. So I'm going to use the load PowerShell command, and it loads the extension PowerShell, successful. Now I can use a question mark to see the PowerShell commands that I can execute. So a couple commands that are here. The very first one is the PowerShell_execute. The PowerShell_execute command will allow you to execute any PowerShell command against that target system. So that'll be the first example that I use, is I'll show you how to execute PowerShell commands using the PowerShell execute command. But then the other thing that we could do if we wanted to is we could do a PowerShell import to execute a PowerShell script file. So again, I'll show you how to do that. You can also remove a session if you wanted to, if you had a PowerShell session. The final command I want to show you as well, and this is how to go into an interactive PowerShell prompt. Okay, so let's start with just executing individual commands. To execute an individual command, I can use the PowerShell_execute Meterpreter command because I've loaded the PowerShell module. And then what you do is in single quotes, you put in your actual PowerShell command. So I'll fire off a few examples here, but bottom line is anything that's a PowerShell command, I can run now within the single quotes. So I'll do get service name SP star. So what I want to do here is I want to get a list of services running on the system. Because I don't want the big list, what I'm going to do is I'm going to filter it out and say, just show me services that start with the letters SP. So I hit enter, and it shows that there's two services that start with SP in the name. There's the spooler service and the software protection service. Notice that the spooler service is currently running. So what I could do if I wanted to is I could do a PowerShell_execute, and I could do a stop-service. The name of the service that I want to stop is the spooler service. And notice that it says it executed that successfully. Now what I'll do is I'll use my get command again to look at the results. And notice that when I use the get command again, and I use my up arrow to go to my previous commands there, Notice that the spooler service is now stopped. So what that's proven to you is that not only can I execute PowerShell commands, but I can manipulate the target system. I just stopped a service on that system. And again, using my knowledge of PowerShell commands. So bottom line is, if there's any PowerShell commands, you could execute those here. Another example, if I wanted to browse through the file system, for instance, I could go and do a PowerShell execute and just a dir :/. So if I just want to start taking a look at files that exist on the hard drive of this target system. Now remember, this is a server, so it does have a bunch of server folders there. It looks like it's a WSUS server, that kind of idea. Perfect. Now a couple other commands. There's the PowerShell execute. This target system is a domain controller, so if I wanted to, I could get a list of the Active Directory user accounts. So I can use my getAdUser, filter*, which means give me all user accounts, and then format the results in a table and just give me the name of the user accounts, is what that does. So when I hit enter here, now I've retrieved a list of all the usernames. Now, I may also want the SAM account name, I think is the property. SAM account name. Yes. So the SAM account name is there as well, which is the logon name. So notice that the Tom Smith account, for instance, T Smith is the SAM account name, so that's the logon name, and G Clark as well. Perfect. So my point is, not only can I go and kind of just retrieve information about that system, but because that system is a domain controller, I can now work with Active Directory accounts, which is kind of crazy. And just one last little example with Active Directory is I could do a PowerShell execute and do a new AdUser command, and I'll create a new user called Course12 PowerShell Hacker. So new AdUser, Course12 PowerShell Hacker. And it looks like it completed successfully. It doesn't like the characters that I used, it looks like, in the name. So it might be too long for a name, but let me just try PowerShell Hacker. Okay, that worked. Perfect. So my point here is, any PowerShell commandlets that you're familiar with, once you load that PowerShell module, you can now execute individual commands with the PowerShell_execute command. But the cool thing is, that's not all. What you can also do is you can go and execute scripts. So I'm going to do a PowerShell_import command. And with the PowerShell import command, you can reference a script file. So I've got a script file in my student directory called course12_script.ps1. Now this script is very simple. I think all it does is do a directory of the C drive, but the script could have any PowerShell commands in it. And the point is as a pen tester, you can prepare your script, then when you exploit target system, load the PowerShell module, and then go and execute your script with the PowerShell_import. So notice that it did give me a dir, so it shows me what's contained on the hard drive of that system. That's only because that's the command I put into the script. And again, I could have put anything into the script itself, but I just wanted you to visually see that when I call the import command, it does execute the script. So you prepare the script and you can execute it. And what's cool about this is that script resides on my pen testing system, but yet it executes against the target because I've loaded that PowerShell module after exploiting that target system. That's very cool. Now, the last thing I wanted to show you here is we can go and open an interactive prompt if we wanted to by using the PowerShell_shell command. And notice that I'm out of the interpreter prompt now, and I'm in a PowerShell prompt. And from here, you can use any of your PowerShell commands. So again, I'll use that get service name sp*, but notice that I don't have to have the PowerShell_execute in front of everything because I'm in a PowerShell prompt, which is nice. Now I can start that service if I wanted to. So start service name spooler. No results in a PowerShell prompt means it was successful. So I'll use my up arrow to go to my, oh, I guess I can't use my up arrow in this prompt. So I'll do the get service name sp star again. And you can see that the spooler service is now running. So again, I've manipulated the system. And in this case, I've started a service that I stopped earlier. And again, I could go and use that get AD user, filter star, and let's pipe that to format table and give me the name and the SAM account name. So you can go into an interactive prompt and then just type your different commands in to manipulate the system. So in this demonstration, you saw how to use PowerShell as part of your attack on target systems. In this demonstration, you'll learn how to use Evil-WinRM to remotely exploit a system. The Windows Remote Management Service, also known as WinRM, is a feature of Windows that allows administrators to remotely connect to a system and change its configuration settings. It saves the administrator from having to be physically at a computer to change its configuration. Evil-WinRM is a tool used by penetration testers that is used to exploit that service to gain access to a target system and extract info from the system or make malicious changes to that target system. Let's first look for target systems that have the WinRM service running. What we can do is we can use nmap to scan for port 5985. So I'm going to do nmap-st-p for port, and it's going to be the 5985 port. And then we can specify which systems we want to scan. In this case, I'm just going to scan the actual system that is my target system, 10.0.0.1. But keep in mind, you could do the whole network by specifying the subnet ID if you wanted to. It's just that's going to take a lot more time. So in my case, I'm just going to pick the system that I know does have that service running. So I hit enter, it does the port scan, and it does show that port 5985 is open on the target system. Perfect. So now I know 10.0.0.1 is a valid target. Again, in real world, I would have scanned the entire network. It would have took a few minutes, but then you'd have a list of systems that have that port open. The next thing that I'm going to do is I'm going to use the evil-winrm command all by itself. And what that will do is that'll give you a list of switches. So if you want to see the help on the command itself, just type the command by itself. So Evil-WinRM, it comes up with the help on that command and shows me a list of the different switches that are supported. And we'll take a look at some of these switches as I continue on through the demo. So for instance, -i is how we can specify the IP address of the target system, whereas -u is how you specify a username, and -p is how you specify the password. So next thing I want to do is use the Evil-WinRM command to make a connection to the target system. So I'm going to do an evil-winrm space -i 10.0.0.1 is the IP address of the target system, -u, and then the username I want to authenticate as, and -p with the password. So this username and password you would have obtained through a credential attack earlier on. So I'm going to hit enter and see if it connects to the target system. And it does look like it was successful. Notice that my prompt has changed. I was in a Kali Linux prompt here, typing the Evil-WinRM command in. But notice that after the connection was established, looks like I'm in the PowerShell prompt of the target system. And at this point, I can start using any number of commands on that system, right? So for example, I'll use the whoami command. And with the whoami command, it reports back who I've authenticated as. So it looks like I'm logged in as quick24x7 is the domain name / the administrator account. If I wanted to, I could then go and fire off any Windows commands. For instance, I could use the net user command to display a list of user accounts that exist on that system. Notice there's a T Smith account, a G Clark account. It looks like there's an Allen account as well, and a Marcia account. So I can see the user accounts that do exist. And better than that, if I wanted to, I could start creating accounts, right? So I could do a net user. I'm going to specify course 12 underscore hacker is the user account. And I'll specify the password, capital P-A $$ W0RD 1234/add. So it's created that account successfully. So my point is, now I've exploited the system and I'm thrown in a command prompt here, I can use any command prompt commands that I want. If I use the net user command again to view the list of accounts, I can see my course 12 hacker over in that third column there at the top. Perfect. So not only can I use Windows commands, but because I'm in a PowerShell prompt, I can also use PowerShell commands. So for instance, I can use the getAdUser-filter star, and then I'm going to say format table, give me the name and the SAM account name. And notice that I've used a PowerShell command to retrieve the user account list as well. So my point is you can use any of the commands from that target system now that I'm in a command prompt. There are other specific Evil-WinRM commands that you can use as well. If I type in the word menu, it'll bring up the Evil-WinRM menu system. And notice that we do have a list of commands here. There's a DLL loader, there's a donut loader, there's an invoke binary, there's a bypass for MSI, there's a services command, an upload command, a download command, a menu command, and an exit command. So let's start at the very top here and just give you a quick description of each of these commands. So DLL loader is used to load a DLL into memory to make the functions that are in that DLL available to the attacker. Donut loader can be used to load code into memory and then execute that code. Invoke binary is used to run an executable file on the target from a path specified with the -e switch of the Evil-WinRM command itself. The bypass for MSI command is very interesting because it's used to disable the anti-malware service on the target system so that you can run malicious scripts or executables on that target system. The services command will list the services on the target system. The upload command is used to upload a file to the target system. The download command is used to download a file from the target system. And then the menu command is used to display this menu. And then finally, the exit command will get you out of the Evil-WinRM prompt, which you can see I'm at the bottom of the screen there in the red. Perfect. So let's take a look at downloading some confidential data from the target system to our Kali Linux system. So the idea here is what you could do is you could use your commands like ls to get a listing, or dir to get a listing of the different files that exist on the system. Now in this case, I happen to be in the documents folder of the administrator account on that system. And notice that there's a file there called customer_list.txt. So I'm thinking, okay, that looks really interesting. What I want to use is the Evil-WinRM download command to download that file. So I'm going to use the download space and then the name of the file, customer_list.txt. And then I'm going to specify that I want to download it to the /home/student /downloads directory /customer_list.txt. So I specify the file that I want to download and where I want to download it to on my Kali Linux system. So I hit enter. It says that it downloaded the file successfully. It's a very small file, so you saw a bit of a progress bar there. Had it been a larger file, it would have taken quite a bit longer, right? But it's a very small text file. So now that it's downloaded, what I'm going to do is I'm going to exit out of my Evil-WinRM. And let's print out our working directory. Notice that I'm in the home student. I want to go to my home student downloads. So I'm going to do a cd/home/student/downloads. And I'm going to do an ls, and I can see there's a file there called customer_list.txt. Now, if I want to display the contents of that file, and keep in mind I'm on my pen testing system now with a copy of that file, I'm just going to use the cat command to display the contents, and notice that I can see, the information that's contained inside that sensitive file. So in this demonstration, you saw how to use Evil-WinRM to exploit a system and extract information from that system. In this demonstration, we'll take a look at how to perform a living off the LAN attack. Living off the LAN, or what's known as LOLBins within your PenTest Plus certification and exam objectives, living off the LAN means that once we exploit a system, what we're going to do is we're going to use commands that are available from that system to continue our attack. The benefit of living off the LAN, or using programs that come with your operating system to continue your attack, is malware protection software will typically go and identify and prevent you from running your malicious tools or your malicious scripts and stuff. So as an attacker, it's good to kind of have a set of operating system commands, or commands that come with the platform that you've exploited, to continue that attack. So let's get started. First thing I need to do is I'm going to exploit the system. And I'm going to exploit the system by our target system by going into MSF console, the Metasploit tool. And with Metasploit, what I'm going to do is I'm going to use the exploit against Windows SMB service. And it's the MS17 010 Eternal Blue exploit. Now with this exploit, what I'm going to do is set my rhost value to the victim system, or my target system, so 10.0.0.10, and then I'm just going to run the exploit. Looks good. It has exploited the system, and notice that I'm in the meterpreter prompt, and within this prompt, I can execute any number of meterpreter commands, which is awesome. Meterpreter has a number of post-exploitation commands that you can execute. So things like trying to retrieve the SAM account database, the password hashes, that kind of idea. Now that we've exploited the system, now what I want to do is go into the shell, or a command prompt, of that system. So if I type the shell command, which is a Metasploit command, it'll jump me into the command prompt of the platform that's been targeted. So in this case, I've exploited a Windows machine, and notice that I'm in the Windows folder there. So I'm within the Windows command prompt at this point, and now I can use any number of Windows commands. The first thing I want to check, though, is what my credentials are, because if you're going to live off the LAN, you're going to execute commands that come with the operating system. And if those commands are going to make changes to the system, you will need to have admin access. And in this example, notice that I am authenticated as the system, which is the operating system. And the system account has admin capabilities to that system. So I'm good to go. And now you can fire off any commands that you want. So a lot of times as a pen tester, once you've exploited a system, what you want to do is plant a backdoor. So the cool thing is you can use your net user command. And again, you could use any commands, but in this example, I just want to take a look at the user accounts that exist on the target system. And maybe what I want to do is I want to create a brand new account that I'll use to authenticate to the system at a later time. And the reason why that's important is because the system may get patched and my exploit may not work, down the road. So planting a backdoor account is very important. And knowing my Windows commands and how to view the list of user accounts, and then also create user accounts, is what I want to do here. So notice that I do have user accounts here, or it looks like the target system has user accounts of user 1, user 2, user 3, user 4, user 5, user 6. So what I'm thinking is, as an attacker or a pen tester, what I want to do is create an account that kind of stays hidden within that naming convention that's being used. So I'm thinking I'll build a user7 account. So I do a net user. I'm going to call this account user7, set the password for that account, and I'm going to add the account. So again, the lesson here is I know Windows commands. So as a pen tester, once I exploit the system, I can use those Windows commands. There's nothing wrong with executing these commands, and any malware protection software that's running on that system won't be triggered by these commands because they're just regular Windows commands. Now that I've added that user account, now what I want to do is put that user account into the administrators group. So user7/add. So net local group, the name of the group is administrators. The name of the user I want to put in that administrators group is user7/add. And notice that it comes back and it tells me that the command was completed successfully. So not only did I create a user account here, but I've now planted that user account in the administrators group. So if I authenticate to the system as user7 at any point in time, I am an administrator of that system. We can do a number of other things as well. So just to kind of show you, I can use the Windows operating system commands to do like a ping sweep. Maybe I want to discover other systems on the target network. So I can do the ipconfig command to display my IP address. So it's 10.0.0.10, and my subnet mask is 255.0.0.0, which means I'm on the 10 network. So if I wanted to, I can use a Windows for loop. So I can do for%i in, and then what I'm going to do is I'm going to supply random numbers. I'm actually going to pick numbers I know that are being used on my network. So 1 is used on my network, 2 is not, 6 is, 7 is, and 10 is. But what I'm going to do is I'm going to go and execute a ping command of 10.0.0. And then I'm going to put %i. So basically what I want to do is I want to use the Windows ping command, but I'm going to embed that in a for loop so that it executes the ping command multiple times, each time using a different number. So the first time, %i will be 1, which means this will be 1. So the first time the ping command executes, it'll be 10.0.0.1, that's ping. Then the second time, it'll be ping space 10.0.0. %i will be the 2 second time. And then third time, %i will be 6, so it'll be 10.0.0.6. So the point is I'm using just a Windows for loop to do a ping sweep on this network. And now I'm not going to ping a whole bunch of addresses, just due to time constraints, but I'll do a couple here. So you can see it's trying to ping 10.0.0.1 and it was successful. Looks like 10.0.0.2 is unreachable, so that system's not up and running. So as a pen tester, I'm kind of making notes here of what systems are up and running and which systems are not. And I record those, and those could be potential victim systems as well. So the point is I wanted to show you that, hey, you can do a little bit of scripting within this Windows command prompt, which is kind of cool. Now, the other thing that I want to do is, and again, these are all just commands that come with the operating system, is to show you that you can do all your file management stuff. Let's do cd / and then do a dir, and I can see, oh, there's a data directory. So I can browse through the file system of the target system. I do a dir inside of the data directory, and I can see, oh, there's a file called logins.txt. Well, let me type out the content of logins.txt, right? So I can see, oh, they've recorded some websites and what their passwords are for those websites. So again, as a pen tester, I'm collecting that information. In this demonstration, you learned about living off the LAN attacks, which involves using programs or commands that come with the target operating system.